Hey guys, in this lesson we would understand how to make the graphs and write down the key characteristics of polynomial functions given in factored form. We have learned in one of the previous lessons that polynomial functions is of three types, or polynomial functions can be written in three different forms. One is called standard form, one is called vertex form, and one is called factored form. If we want to draw a graph of a given polynomial function, this is the best form, that is the factored form. Factored form can be easily turned into a graph using few steps. These steps we would discuss in this lesson. If we are given a polynomial in standard form, then we first have to change it to factored form, and then from the factored form we'll get the graph using the same steps. Let's say if we want to change the vertex form into graph, whenever we are given a vertex form, the only thing that we use is the mapping formula. And mapping formula we have been doing in the previous classes as well. It's x over k plus d, ay plus c. So we would figure out the transformation parameters k, d, a, and c and apply these parameters on the parent x and y values to get the new points and turning those points into a graph. Vertex form we'll discuss in the next lesson. However, in this lesson we would discuss how to turn factored form of polynomials into graphs. Just remember for the later units that the standard form of polynomials cannot be directly turned into a graph until it is converted to the factored form. So for that we would have to learn factoring of standard form to factored form. Once we learn the factoring, then we can apply the same steps that we are going to learn in this lesson to turn the factored form into a graph. Let's say we are given an equation fx equal to negative x minus 4x minus 1x plus 5. We know this is in factored form because it's a bracket form. There is no a value, but there is a negative sign there. That means a is negative 1. Now the steps for converting a factored form into a graph is, step 1 says check the degree of graph. And we already know that if a given polynomial is in factored form, the degree is always sum of the powers on these brackets. If there is no power, that means the power is 1. So we add these 1 plus 1 plus 1. Degree is 3. Here we would want to know one more thing, that these 1, 1, 1, these values also have a specific name, or the powers on these factors are called orders. So the order of x minus 4 factor is 1. Similarly, order of x minus 1 factor is also 1, and order of x plus 5 factor is also 1. When we add up all the orders, we get the degree. So we can write here sum of orders is called degree. Step 2 is check the sign of leading coefficient. In this particular case, the sign of leading coefficient is negative. Step 3 is use step 1 and 2 to determine the quadrants of the endpoints of the given function. Because we know the degree is odd and the leading coefficient is negative, odd means it has to be diagonally opposite, either 1 and 3 or 2 and 4. 1 is the endpoint seen for positive leading coefficients. 4 is the endpoint seen for negative leading coefficients. Therefore, it would be quadrant 2 and 4 because we have a negative leading coefficient. So the graph that will be drawn from this function will have its endpoints in the second and the fourth quadrant. Step number 4 is to mark the zeros or x-intercepts of the function on the coordinate grid. So if this is our coordinate grid, zeros we always get from the factor. So first factor is x minus 4. Therefore the 0 is going to be, we put the factor equal to 0. X is equal to 4 is the first 0. Second is x minus 1. We put x minus 1 equal to 0, so x is equal to plus 1. Next is x plus 5. When we put x plus 5 equal to 0, we get x equal to negative 5. So these three numbers are the zeros of this function. We'll mark the zeros. 1 is -5, let's say it's here. Next is 1, let's say it's here. Next is 4, let's say it's here. And we already know the endpoints are going to be in the second and the fourth quadrant. We can mark that here as well. Next is step 5. That is very, very important step. So we have to check the behavior of the graph across the 0. And what does this mean is we can only check the behavior of the graph across the 0 with the help of the order. So we would use the respective order to check the behavior of the graph across the x-intercept. Now in this particular example, when x is 4, the order is 1. And we already know orders are these powers. So when x is 4, order is 1. Similarly, when x is 1, order is again 1. When x is -5, order is again 1. When x is 1, order is 1. When x is -5, order is 1 again. Now how order helps us decide the behavior of the x-intercept is if ever order is 1 at a particular x-intercept. For example, we'll take an order 1 for x equal to 2. This is some random example. When order is 1 for x equal to 2 and the graph is coming from here, then order 1 means the graph is going to pass straight through 2. If order is 2 for x-intercept 2 and the graph is coming from here, it's going to turn around at 2. So order 2 means turning around. Order 1 means going straight. If order is 3, then at 2, if the graph is coming like this, it's going to go squiggly. However, it's going to pass through it. And if order is 4 for x equal to 2, this is also for x equal to 2. And if we're coming from here, we're going to turn around like this. This is how the orders are going to help us know the behavior of the graph across the x-intercept or across the 0. Now going back to the same question that we are doing the example for, we know here x equal to 4 is order 1. This is also order 1 and this is also order 1. Therefore, the graph is going to go straight through these x-intercepts. So when x equal to -5 is the first thing we would check, we always start making the graph from the left side. Now because one end of the graph has to be in the second quadrant, we have to come and hit -5 from top like this, and it has to go straight through it. Then turning around, we do not have to worry about where we have to turn around, but we have to turn around because we have to cross through this x-intercept as well. Here also we'll go straight because order 1, and then we would have to turn around somewhere and we have to go straight because of order 1 as well. So this is how the general sketch of the graph would look like. It's not a specific graph because these turning points are not known. Turning points will be given in the question. If they're not given in the question, then we would just make a sketch like this. Just to make the graph more specific, we can add step 6 to it. Find the y-intercepts. In this example, how do we find out the y-intercept is? We have fx equal to -x minus 4, x minus 1, x plus 5. For finding the y-intercept, we put in x as 0. We get -4, -1, and 5. So all we have to do is just multiply these numbers. 5 times 4 is 20 times 1 is 20. There are 3 negative signs, so it's a -20. Now how do we show this y-intercept on the graph is? What we would have to do is, let's say our y-intercept is -20 here. We can make the graph one endpoint on the second quadrant. So graph is coming like this, going through 5 straight, turning around somewhere, but hitting the y-axis at -20. So this is more specification added to the graph, that it has to meet the y-axis at -20 and then keep going up, 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 meets 1 because it's the x-intercept, goes straight through 1, turn around somewhere, and goes straight through 4. In this particular example, we're not given the turning points. If you're given the turning points, then we have to make sure that we turn around at that specific point. So this turning point should be specific according to the question if given. If not given, then this is the right graph. So step 7th would be applicable if it's given. That is, apply turning points to the graph if given. And this is the final graph that we get using all these steps. If let's say we were given the question as this and we were supposed to sketch this into a graph, then we would apply all the above steps that we have discussed before. Step 1 is to find out the degree. We know degree is the sum of the orders, so it's 2, plus 3. That's this plus this, and it gives us a 5 degree. Second, we have to know the leading coefficient sign. It is positive. We notice here there is no sign, means it's positive. Third is we get the x-intercepts or the zeros. So the first x-intercept is taken from this factor. It's just x. So we put x equal to 0. That's the first x-intercept. Second is when we put x minus 6 equal to 0, we get x equal to 6. This is the second x-intercept. Fourth is we use the orders to check the behavior. So when x is 0, order is 2. When x is 6, order is 3. Fifth is we get the y-intercept. For getting the y-intercept in this particular case, we would put in x as 0. Because y-intercept is the value of 5 and x is 0. So 0 square is 0 multiplied by anything is 0. So y-intercept in this case would be 0. We're not given any turning points. So we would use all of these 5 steps to sketch the graph. This is our grid given. So we would use step 1 and step 2 to decide the quadrants for the endpoints. Because it's odd degree and it's positive, it has to be quadrant 1 and quadrant 3. Then we would mark the zeros. The first x-intercept is seen at 0. Next x-intercept is seen as 6. The step is done. Next we have to start making the graph, checking the orders and using the y-intercept. So y-intercept is 0, so that's here itself. Because the endpoint lies in the third quadrant, so graph is going to come from here. When the graph comes from here, now it will not go straight through 0 because at x equal to 0, order is 2. Order 2 means it's supposed to turn around. We do not know the turning point, so we would turn anywhere else again because now we have to cross through 6. And at x equal to 6, the order is 3. We know when the graph crosses through an x-intercept with order 3, it goes through it but in a squiggly manner like this. And this is how we get a graph of a given function using all of these steps. And we have got the sketch here. Now, if the question had asked us to write down its key characteristics, how do we write those? Once we draw the sketch, then we can use the sketch to write down the key characteristics. The first is domain and range. Domain is XER. We notice that there is no limit on the x value. Range is YER. Second is symmetry. This graph has no symmetry because it's neither symmetric about origin nor it is symmetric about y-axis. Third is x and y-intercepts. We know x-intercepts are 0 and 6 and y-intercept is just 0. That's this one. Next is we write down the end behavior. So when x approaches negative infinity, y approaches negative infinity because it's in the bottom quadrant. And when x approaches positive infinity, y still approaches positive infinity because now it's in the top quadrant. Now these two are fifth and sixth are going to be very important characteristics added to this graph. So whenever we are asked to write down the key characteristics, we have to write on all of these 6 characteristics. The fifth one is positive negative intervals. Positive interval is the interval where the graph is above x-axis. So this is the portion where the graph is positive. Everywhere else the graph is negative. So everywhere else the graph is negative. So this is all negative graph. Therefore, we would write down the negative interval of the graph is, whenever we write down negative and positive intervals, we have learned this in the previous unit, we go from left to right. So we are coming in this direction. We see this graph is going to start somewhere on the extreme left. We don't know where. So we would say negative infinity to 6. So from negative infinity to 6, the graph is all negative. And how do we write down? We write down a bracket, negative infinity to 6. This is how we show interval notation. Next is positive interval is from 6 to positive infinity. So it starts at 6. So this is all positive section of the graph. Starts at 6 up to positive infinity. And that's it. This is how we write in positive and negative intervals. Next, the sixth and the last characteristic that is again very important is increasing and decreasing intervals. Again, it is talking about intervals, so we have to go from left to right. So we check the graph from the left side. We are basically moving on the graph from left to right. And we notice that when we start coming from left, the graph is increasing up till here. So the increasing interval for this graph is from here to here. This is all increasing. Then it turns around and starts decreasing up till here. then it starts increasing afterwards. This squiggle does not mean it's turning around, so it's all the way increasing up, up, up. Therefore, this graph is going to have an increasing interval from negative infinity to 0, and is written with a U sign in math. Now we do not know the turning point, so let's assume if you're not given a turning point, wherever you're turning around, you can just assume that x value there. So we would notice that this graph is going to turn around at 3. So from 3 up to the infinity, it's again going positive. So 3 to positive infinity, it's going up, means it is increasing. Next, we have to write down the decreasing interval, and we notice that the graph is only decreasing in this section where it is going down. So from 0 to 3, this graph is decreasing. And this is how we write down the increasing, decreasing, and positive, negative intervals. These 6 characteristics are very important. If we are not given the turning point, wherever we are turning, we would take that x value as the change point for increasing and decreasing intervals. And if we are given a specific turning point in the question, then we would use that x value of the turning point. Because for increasing and decreasing intervals, turning points are going to decide. Now this was the turning point, this was the turning point. So turning points are going to decide whether it is increasing or decreasing. Now another type of question that can be asked from this particular section is that write the equation of the family and then state 2 functions that belong to the family that has zeros at x equal to -1 and x equal to 4 with order 3. Also determine the equation if the graph passes through this point. So let's do first part A. Now always remember, guys, whenever we are writing the equations that contain the same factors, they belong to the same family. That's why they say equation of the family. So how do we write down the general equation is fx equal to A, and here we can write down x minus r, x minus s, x minus t, and so on, depending upon how many factors we are given. Because we are given 2 zeros, so that means we would get 2 factors. Therefore, we do not need the third bracket here. Now, all that we have to do is just sub in this x equal to -1 back into this first bracket. Write on A as is, so it would be x plus 1. When we put this back into the bracket form, it's always in the opposite sign. Here we have x minus 4. Because the order is 3 for this, so we would mark on the second bracket 3. No order specified here means order is 1. So this is the equation of the family. A family would have the same factors with same orders. It's just that they would have different A values if there are different members in the family. So write the equation of the family. This part is done. Next part is state 2 functions that belong to the family. So now they want any 2 members of the family. So this is the family equation. When they have asked you to write on any 2 functions or any 2 members, then what we have to do is just put in the A value as any number of your choice. The answers are going to vary in this case depending upon your personal choice. So if I want to put A as 1, I can put A as 1. This is x minus 4 to the power 3. Another member equation I can write down is by putting A as -2. It's up to me or it's up to you. Whatever A value you want to put in, you can put in there. So this is any 2 members because they have the same factors. That's why they belong to the same family. Why are they called different members? Because they have different A values. So this completes our part A. Next, they want you to determine the equation of the graph passes through point this. Now, when they give you a point, they want you to find out a specific member. When they give you a point, specific member means a specific A value. Now, how do we find out the specific A value is? What we have to do is just write on this general equation. That is a general family equation. And in this general family equation, substitute this point as x and y. So x is -1, y means fx, that is 1. So I'm going to put in here 1. X is -1, -1 minus 4. Let's not take the point as -1, let's make it -2 because I made the question. So now x is -2 and y is 1. What are we going to do here is just solve for A value. So this is going to be -2 plus 1 is a -1. -2 minus 4 is a -6. To the power of 3, and here there is a 1. We are isolating for A. That's what we are doing here. This is -1. -6 to the power 3 is a -216. So this is -1 times -216 times a is 1. Therefore, a is equal to 1 over 216. Now the equation is going to be fx equal to 1 over 216. In the bracket, we have x plus 1 and x minus 4 to the power of 3. Now the difference between part A and part B is part A wants you to write on any two members, so we can write on any of the A values, whereas part B wants us to find out the specific A because they have given us a point where x and y coordinates are known. Now let's say another example, that is the last example that can be asked from this type of lesson, is write the equation of the function for the following graph. Whenever we have to write on the equation, we have to first write on the x-intercept. So the x value is -1. Around the x-intercept, we have to check the order because the graph is turning around at -1. So this order is supposed to be 2. Next is x equal to 2. Order is supposed to be 1 because it's going straight through it. Next is x equal to 4. Order is supposed to be 1 again because the graph is going straight through it. Then we have to put these x-intercepts in the form of an equation using the factors. So fx would be equal to a. The first x-intercept is x equal to -1. We put it as a factor with opposite sign, so it's x plus 1. Next is x equal to 2. Opposite sign means x minus 2. Next is x equal to 4. Opposite sign means x minus 4. Order of x equal to -1 is 2. So power we'll put as 2. Next is power 1, power 1. This is how the general equation of the family would look like. Because we are given a point, we have to use this point to put in as x and y coordinates in order to solve for a specific a value. We know x is 1, so we'll sub in 1 everywhere. And y value is given to us as a -12. When we solve this, we get 2 squared. This is -1, this is -3. We get 2 times 2 is 4, times -1 is -4, times -3 is 12. So we get a times 12. Always remember, this is all connected with multiplication sign because it is the factored form and there is a -12 on the other side. So we isolate a by dividing -12 with 12, and this gives us a -1. Therefore, the final answer is going to be fx is equal to -1, x plus 1 square, x minus 2, x minus 4. And this is our final equation for this particular question.